Okay, in goal 2.1 and 2.2, we're solving non-fraction equations. Even though they're not fraction equations, I thought instead of waiting to give you the set of rules, I'm going to give you the set of rules right now. So rule number 1 is if there are fractions, get rid of them. And we're going to specifically talk about that in goal 2.3. Okay? After you get rid of fractions, then do the grouping symbols. Get rid of your parentheses, your brackets, etc. Probably one of the biggest things that people don't do that make it more challenging for yourself is that you don't do this if it's possible. Collect like terms on each side. If you have like terms on the left side of x, put them together. If you have like terms on the right side of x, put them together. Then you're going to move the x's to one side of equals. You're going to use addition or subtraction to do that. I typically like x on the left side every time. Some people move x so that x is positive, so whatever way they want to move it, that's fine. I typically move to the left. There's only like one case when I don't. But it won't matter. You can do whatever you want. Then you're going to move your constants to the other side using addition or subtraction. And then you're going to get x alone. And that should almost always be a division if you've done this. Okay? So this should almost always be a division to get that x alone. Okay? So again, I realize that I'm starting out pretty elementary, but I think it's important because I do have advanced students who have done everything in their head in the past, and that's not going to work. Okay? So you've got to know from the beginning, then we're building on it up till goal 4. Okay? I'm going to show the steps. In all of goal 2, I will write out what I am doing. I hope that after, or maybe during, after goal 2, that you don't need to see that anymore. Okay? I'm going to do it all of goal 2 though. All of goal 2, I will write the steps that I'm doing. I don't typically do that when I do math myself. I just do this step, but I'm going to write it for you through our notes, all of goal 2. Okay? Hopefully you understand what an equation means. An equation means that the left side and the right side are equal to each other, even though they look different. And if you're going to keep them equal, you have to do the same thing to both sides, or it's not equal anymore. Okay, so that's important that you're doing it to everything, both sides. Okay? One of the things you'll see when we do fraction equations is that understanding how many terms there are in an equation is important. Okay? All right, so question number 1, I want x alone, so I'm going to get rid of a -4, which means I'm going to add 4. So x, they give me 0 equals 26. In this chapter, every answer is checkable. You should know before you turn in a paper, if you have the time, if you got 100%. Because I should be able to go to my calculator. I know this is a simple one, but just go. 26 minus 4, enter. Does that give me 22? Okay? Every answer is checkable. I'm not asking you to do it. I'm just saying you could do it. Okay? Negative x plus 5 equals 11. So I'm going to subtract 5. So negative x equals positive 6. Never leave your answer negative x or opposite x. I want it positive x. So you are then dividing by a -1. Mathematically, that's what you're doing. You don't really have to show that. If the opposite x or negative x is 6, then I just change the signs of both sides. And x is a -6. But mathematically speaking, what you're doing is dividing by a -1 to make it positive. On my next one, I'm going to subtract 37. And I get -11 equals negative x. Divide by -1. And x equals positive 11. I have a grouping symbol in this next one, so I'm going to get rid of that, which means I'm going to distribute this negative. We did have quite a few, more than I would have anticipated, people who missed one question. It was a distribution of a 2, it was a -2, and they missed the negative. I mean, a lot of people, actually more than I would have anticipated. So let's not do that again, okay? Negative to a positive makes that -6. Negative to a positive makes that -x. So that negative is distributed to both of those terms. This is what I was talking about earlier, that if you have like terms that can be combined, do that before you start moving from one side to the other. So 4 minus 6, -2. Now I'm going to add 2 to both sides. So -x equals +5. And again, I'm going to divide by -1. And x equals -5. And this is a good one to check. You know, maybe those other ones weren't, you know, real necessary, but like this would be a good one. I go to my calculator and I punch in 4 minus parentheses. You got parentheses on your calculator. 6 plus -5, close parentheses, enter. Do you get 3? Okay, because that's an easy one to make a mistake on. All right, here we're multiplying, so we're going to divide to undo. So divide by 5. X is -9. Divide by -17. Don't add it. X is 0. 0 divided by anything is 0. Here I'm going to move my constants. I got my x's on the left. I'm going to move the constant terms to the right. So I'm going to add 9. And then divide by 5. And x is 16. Here I have parentheses, so undo the parentheses first. Distribute 8x. 8 times 1 is 8. Minus 3 equals 48. Collect those like terms. So I have 5. Positive 8 minus 3. Subtract 5. And 8x equals 43. And divide by 8. I am good with leaving it as 43 over 8. It's reduced. It's improper, and that's fine. If you want to change it to 5 3/8 or 5.375, that works. Terminating decimals are fine answers. Repeating decimals are not. Convert something like a repeating decimal to a fraction. Okay? As long as it's reduced, your directions will always be leave answers in simplest form. Okay? So 43 over 8 works for me. Most times people look at that, they're like, oh my God, I did something wrong, I got this fraction for an answer. Oh, go plug it back in your calculator. 8 parentheses, 43/8 minus 1, close parentheses, minus 3, enter. Do I get 48? Check it. Okay? All right, this time my like terms are my x terms. So collect those first, 15x. Minus 7 equals 8. X term alone, so I'm going to move my constant to the right, add 7. And lastly, divide by 15. And x equals 1. This mistake was made on your assessment that you just got back. We did talk about it. I'm going to start again. -9 minus 3 times multiplication. Multiplication comes before subtraction. So the distributive property comes first. Do not take -9 minus 3, get -12, and then distribute. Several people did that on the assessment you just got back. Okay? Distribute first. -3 times 2x is a -6x. -3 times -1, positive 3. Equals -18. collect these constant like terms. -9 plus 3, -6. Get that x term alone, so I'm going to add 6. And then divide by -6. And x equals 2. And my last one for this goal. Brackets, parentheses, double grouping symbols work inside and then out. So nothing is changing on this outside. I'm going inside and I'm going to distribute the negative. So negative to a positive makes it -1. Negative to a negative makes it positive 2x. Collect like terms. I like to finish my grouping symbols off. You could distribute first and then collect your like terms. I like to collect like terms and then distribute. Now I have a distribution again. My -3 times my bracket. So -18 minus 6x equals 0. Collect your x's, and I have -x, -1x if you want. Minus 18 equals 0. I like x's on the left, so I'm going to leave it there. I'm going to add 18. So -x equals positive 18. And then divide by -1. And then -18 is not. So again, every answer is checkable. Plug it back in. You're solving for the value of x, so that means what you get should work in that equation.